Hi guys, welcome to part 6 I think of our text refactor, text model refactor. So we took some time away because we had a lot of work that we still wanted to get on very quickly, and the video is not particularly good for that sort of stuff. So since we last spoke, we managed to get all the helpers moved across. As you can see here, they're all in the right place now, the text model. We also, that involved quite a lot of finessing, I guess. Here's the sort of helper chain and so on. We also managed to create a common interface for the transforms. So this guy, no, not this guy here, model text transform, that now has an apply method. Now we kind of stopped at the point where we implemented the repository in the registrar. So we don't have the repository registrar moved yet, but that's going to be the purpose of this video, I guess. We're just going to implement these guys here. As you can see, we've hollowed out most of the model now, and even the profiles have also been moved across and are being used from there. We can't get rid of these guys just yet, I think, because yeah, these have to move when these guys move because they have references to them. So that's going to be a problem. In fact, I wonder. So we have a part ID reference somewhere. Where is it? Part ID. Here we are. Part ID. MASD.cpp.public headers. And there's the public headers. I wonder how it knows it's MASD.cpp. In theory, comes from the backend, I guess. Backend name is CPP. Everything has to live in the namespace MASD. So I'm not entirely sure how exactly this stuff is working at present. What probably is happening is we are probably we're probably picking up the parts ourselves manually when we generate the PMM inside of the orchestration, and we probably have a reference specifically to these guys here, or maybe even actually more likely we are picking up the backend. Yeah, that's what it is. So we are picking up the backend, and the backend picks up the parts. So it will be whatever parts are inside of the backend, and because at present we are only extracting the helpers from these backends, we're just ignoring these parts here. So it's more by luck than anything else, but this is kind of working at present because these guys here are referring to these parts, and then when we move them, hopefully what would happen magically is that it will just refer to these parts here, and in theory everything should just work. Of course we will then have other problems, which is we need to take into account the facets and archetypes as well, instead of just the helpers. So there will be some effort required in merging these together whilst we're in this transition phase where we have elements in both the technical space specific models as well as the general model. So that's going to be a problem in itself, but we'll fight that war when we get there. For now, what we'll first start us concerning ourselves with is we need to just implement, we just need to somehow get the workflow to use the registrar and the repository for the text model, and to get all the initializers to point to that guy instead. So if we have a quick look, model to text chain probably will be the guy that owns. We should start clocking, I guess. Probably 30, I guess. So model text chain, yeah, as you can see here, we already have some kind of registrar. In fact, this guy here. That's probably a static, and interestingly enough, we have a pointer for the technical space chain. Not quite sure why that needs to be a pointer actually. Let's just do it without making it a pointer, see what happens, and then if we need to make it a pointer, we'll make it a pointer. Now, one thing we did was we put it on the model to text chain. I think that's a fine place to have it in, because what we really want is in the future the model text chain. So this will be removed, and then the model text chain will execute something roughly like what we call the workflow at present. Basically, a combination of these two guys here. And once that's there, I think we're more or less there. I think. Okay, let's go with that then. And then finally, of course, we need to create some kind of helper to contain all the stuff that's in the assistant. That probably be the next thing to do after we've done these guys. We go for the assistant. Right, cool. Okay, let's start then. So I think the best bet may be to we have to do this in one go, so this is going to be a bit big, but the best bet is probably to just look at the transforms and look at all of the initializers. And then as you can see here, the initializers are initializing. Oh, in fact, what we might even do is we might take this opportunity to get rid of the initializers altogether in the technical space specific models, because we already have initializers in the other model, the common model. So let's see what will happen if I initialize from here. Yes, exactly. So we could, a bit of a hack here, but we could go across models as we did for the helpers in the beginning. So if we just do something like CPP, and then in here this will then become whatever that was. So transforms, that sounds about right actually. Transforms and then build. Yeah, that should have worked. In fact, I think it did work. So hopefully these will go through, and then we just need to do the same hack as we did previously, which was we did something like using text.cpp transforms, presumably, build, something like this. Right, so there's some problem still going on here. So I think the problem is mainly to do with how we're initializing. Let's have a quick look. So I think we will find that there is well, to be honest, the initializer is not so much the problem, it's going to be the registrar, presumably. So around here. Right, so there we are. So around here we have a registrar. Yeah, so we need to change. Okay, so that's fine. I think we got the gist of this. We need to change the signature of the initializer to take one of these guys as well. That could be done probably at backend level. Yeah, this guy here contains an initializer that takes the helper registrar, and then this guy here presumably, oh, interestingly enough, it's also supplying the registrar. So let's go up one level. So presumably this guy is the guy that then says, okay, I know what I'm doing, you don't have to tell me. Okay, cool. So let's just drill through these guys then. what we'll do is we'll just... So one of the things that we've done since the beginning of Dogen, which was a mistake, we always put last the include for the HPP on each CPP, and there's actually good literature that demonstrates that this should always be first, because what this does is it enforces the fact that the headers must compile in isolation, whereas by putting it last it means that sometimes we have dependencies that are fixed by these guys here. This is not backlog, we have at some point to address that issue, but for now we just keep the same approach everywhere, make it consistently wrong. Right, so we have the helper registrar. Just for a laugh, I'll put this guy first. Let's call this TTRG, text transform registrar. And what we'll have to do then is we're just gonna have to do the same drilling quite a few times. Nothing particularly exciting, sadly. We'll just do this across all initializers. Yeah, so we decided to do a video for this work, and then as soon as you get to slightly more boring stuff, which will hopefully take about an hour and a half, we will then do that offline, I think, because once we get to the bits that are just adding the formatters, as we used to call them, the model text transforms to the common model. Once this sort of gets into a rinse repeat sort of pattern, probably doesn't have a lot of value to record videos, and it actually detracts from the speed at which we can do things, so it's sort of a two-in-one really. So we'll just have to do all of these guys. I'm sure there are better ways of doing this. We could just create a macro and so on, but sometimes one becomes lazy, to be honest. I mean, we could have, for example, grabbed. You could tell that my brain is not fully functioning, because we could have easily grabbed for the initializers and then do a bool grab, which would simplify the task quite considerably, because you wouldn't have to be jumping up and down directories. But I guess sometimes you just have to do things the slow way. Also, it takes a while for the brain to warm up when you start coding. I find anyway. See if it fits it. No, it doesn't. Right, so as you can see here, I must have the C++. And of course, as I keep saying, this is also temporary work, because in reality there is no need to do any registration. One of the initialization here. One of the things we found with Dogen is that a lot of times, or oftentimes at any rate, when we in typical programming, when we create abstractions and leave things for runtime, one of the things that Dogen made me realize is that half of the time we do that, it's mainly because we like to make the code simpler. In other words, we don't really need, say for example using dependency injection, DI. Half of the time you actually know what the dependencies are, and you know exactly what's going to get injected. So it's not so much that when you're doing dependency injection, you're trying to generalize the code such that it's possible at runtime to change what's being supplied, or it's actually almost always going to be a very small number of well-defined classes that are going to be involved in those relationships, and you almost always know exactly what these classes are at compile time. The only reason why we end up creating these interfaces and creating these abstractions is because we just need to be able to hook in normally two different classes, the mock and the actual implementer, and because of that we end up paying the cost of having this huge I don't know if you're used to coding in C# like I am at work. You have Castle, you have all these other complex frameworks that give you all the infrastructure that you need in order to do DI. And a lot of the time those things are non-trivial. A lot of the time when you have problems with Castle, for example, you spend a lot of time trying to figure out what's going on, because there's so much runtime magic and so much incantations. If you were to actually hardcode things, I mean the good olden days, you would do something really silly like you create a macro, for example, and the macro would be test or dev or something like that, and depending on which one you're compiling for, the macro would then determine whether to use one implementation or another. Now that's obviously we don't like macros, etc., etc. But there was one advantage of that approach, which was you could always see exactly what code is being generated. Whereas with things like Castle, I find a lot of times it's very difficult to understand what's going on, because there's so much runtime magic, and it takes even the experts, because no one really is an expert in Castle unless you're developing Castle itself. You tend to just use the bits of Castle you need to get something done, and then you move on. Which basically means that every time you have to go back to Castle, you have to start from first principles and try to remember what on earth were you thinking about last time you touched it. And what is going on here? I think we just need... Oh wait, there's two things we need to do here. We need to first update this to the right registrar. And second, we need to see... Right, so as you can see here, the registrar is not supplying us with a registration function. Let's just see what the helper registrar does. Yeah, it should have something like this. And so the crux of it, the thing is that whilst DI is great and we all love DI, let's just call this text transform. Sometimes it's good to think from first principles and try to understand what exactly is it that you're trying to achieve with DI. And sorry, let me just complete this because my brain is short-circuiting, I think. So if you have a register text transform, and then we could just say register transform. Not quite sure we call that register helper transform, given it can only register helper transforms, but there you go. Right, so now what happens if I call perhaps this guy here? Now we still have an issue, which is we don't seem to be... okay, using namespace. Oh. Right, okay, so that looks quite good. Now you can see we are doing the right things. I think before we go any further, we probably should make sure that the initializer... let's just start from the top to make sure this all makes sense. So here we have a helper chain, so presumably we'll need model to text chain. Ah, interesting. Right, I think this is in the wrong place, I think. Right, so I think that's the wrong place. That's why we couldn't find a method. And here we could say, let's call this guy, and then let's call these the helper So what was I saying? I was basically saying that my general conclusion is, and this is some part of the experimentation that we haven't quite done in Dogen, but the question I've been asking myself is, I wonder if there is a model-driven approach to capture patterns such as those. Oops, we are getting the wrong registrar here. This is the guy we want. Okay, that looks off, yep. And now we supply the registrars, we just need to then follow it through to the different initializers. So it's not obvious yet whether there is any merit to this approach of considering these things as structural patterns. So, sorry, going back to what I was trying to say. So the idea then is that, or the question, the scientific question I guess one was asking is, could it be that the main reason why, going back to the macros and to the old days, could it be that the main reason why we ended up developing all of the dynamic infrastructure to do things such as, not sure why this is not working. Clearly, so that looks good. I wonder if it's just the case that we skipped. No, actually, it is this guy, isn't it? So we're in transforms. Oh, I'm not entirely sure this should have worked. Right, so we're calling C# to C++, and we're calling its header, which is this guy here. That looks healthy enough. Text transform registrar. Static. Can't see anything wrong with this. I wonder if LSB is having a bit of a fit. No, it's definitely something not quite right here. Let's just make sure we're doing the right thing. So, initializer HBP inside of transforms. This guy here. Definitely right namespaces. Initializer. Initialize. To the what's that? We just seem to have randomly copied the wrong thing. Okay, so now what we'll do is we'll just make sure that we did not forget to do the C# initializer, which we probably did. So going back to what I've been trying to say for the last 10 minutes and keep getting distracted, what I'm asking, and I haven't really had the time to do this properly, but I think it's definitely a question worth asking, is could it just be that one could replace the macro-based approaches to things like DI? I mean, I don't want to focus too much on DI because I think DI is just a class of things. Just happens that DI is such an obvious one, but there's many other cases of this sort of thing, where we push things to runtime, and we push these things to runtime purely because we don't really have a good way to express these sort of static relationships, and it would be nice to see if you could, as an alternative, code generate these relationships instead of using macros or pushing them to runtime. Now, I can't really talk too much about it because I haven't really done the analysis that's needed. So presumably this is register text transform, I guess. So, because we've been busy with real work, we haven't really done the analysis that's needed to determine how exactly that would work. But the gist of it would be something like, so you declare, so let's think about this. You declare your interface, and hash. you declare your interface and namespace, and then Dogen would have the ability to know what that interface maps to. Um, And then, so for example, if you take the case of the transforms where we're using initialization, the truth is we don't really necessarily need initialization, and we don't necessarily need to know at runtime what transforms to execute. The problem and the reason why we end up actually creating all this dynamic runtime stuff is every time we add a new transform, or every time we add a new transform in this particular case, no one wants to have to then go manually, have to then go and say, oh look, there's yet another transform, please run this one as well. I mean, that's exactly what we're doing at the moment in cases such as these. So if I take logical transforms, in cases such as these, we posited exactly that. We said, do you know what, before we decide that all these things should register, we should have some kind of generic runtime thing, what we're going to do is we're going to manually call the transforms on each of the chain, just call the transforms that you need. And after a while it gets really boring because you start to see, well, this is a bit painful, isn't it? I mean, you have to just call this guy and then call that guy and then call this guy. And the reason why we kept this manually for now is purely because there's dependencies between transforms, and so it kind of makes sense for now to keep it manual, because in addition to registering the transforms, you also need to create a graph of dependencies. So that can be done. It's not that hard. We have graphs elsewhere, but it is work. The reason why we didn't take that approach with text transforms is because there is no such thing. There is no dependency. You can run these things in any order. It doesn't really matter. So it's really easy to create a registrar for this and then to just run through them. But then at that point you start to ask the more fundamental question is, why do you need to do these things at runtime? Well, because you don't want to write that really boring code of run this guy, then run that guy, run this guy. It is not as if you are choosing to do these things at runtime because you don't know what you're going to do at runtime. And that's the important distinction one has to make here. If you have cases where there is a certain amount of uncertainty as to what needs to happen at runtime, then that's fine. You should actually do those things at runtime. But in a very large percentage of the cases, it seems to me that you know everything you need to know at compile time, and you push all this work to runtime purely because you can't be bothered to write things manually. And in those cases, that's exactly where code generation should help, because at the end of the day, if you can localize, if you can create a pattern, and you can say, yeah, well, and then for each of these do that, well, that's exactly what the code generator is there for, right? And so our hope is that at some point in the near future we will move away from these initializers and so on, because what the initializer is doing here, and this is the methodology that we're developing, what the initializer is doing is capturing the pattern. And now you can see quite clearly what the pattern is. The pattern is you basically are going to be, well, actually this is the pattern of registration. So the first step would probably be to say, well, why don't we just generate an initializer? But then if you think one step ahead is, why do you need an initializer at all? And then you can say, well, you could just generate a chain that literally goes through each transform and runs them. And then if you do that, then suddenly you don't really need an initializer anymore. You don't need a registrar. You don't need any of that, because all the stuff that you know at compile time is sufficient to give you the structure you need in the code. And that's kind of the direction we're taking with Dogen more and more, is that we're now starting to question why we do certain things at runtime. Is it really because we should do it at runtime, or is it just because you know, it's not scalable to do it at compile time, because you at the moment we're doing it by hand, so you know, it's just not scalable to do that by hand. Once you have something that becomes n, so for example, we're going to always have n transforms. That number is just going to grow bigger and bigger. So once that number becomes n, that's where the interesting things become interesting, really. If it's something that's bounded, that you know exactly it's a constant number, then it's not so interesting. But anyway, we got a bit of a distraction here, so let's just focus on the task at hand. See the problem of doing some boring things that you get distracted. Not sure why I keep pressing the wrong keys here. So what we really want to do is just go through these registrars. It is quite paradoxical, really, that to create a code generator, you end up having to do a lot of hand coding. um, it's almost one of the reasons why we created a code generator is because writing a code generator is quite boring and requires quite a lot of handcrafting. And every so often we just get bored of doing something and we say, oh, how do we automate this? Can't be bothered doing all this by hand so many times. And so the code generator ends up becoming not sure where the H came from. The code generator ends up becoming a great driver for the code generator, if you see what I mean. Because a lot of things you're seeing in the code generator perhaps are not exactly the sort of thing you'd see in normal code. Some of the things are, but not everything. Right, you keep. No, that's correct. Let's just memorize this so that we don't have to do this again. ODB. And the other thing as well that we are learning over time is that the more integrated with Emacs we become, the better. And I'm sure, I mean, I always talk from an Emacs perspective. I'm sure the VI listeners out there are probably saying, well, you can do all of this in VI. And I'm sure it's probably true, but I just don't have experience with VI. I'm a very basic VI user. What I suspect is that the more you start integrating with Emacs, the more it becomes a text editing problem. And we have a lot of tooling for text editing. Emacs is a massive toolbox with lots of functionality. It's evolved over the years, which means that's kind of the big lesson we learned with graphical editing, is that graphical editing is good because it appeals to our visual senses, and of course we're humans, we're Homo sapiens, we function very well. What's going on here? It seems we've mangled something. Type. I'm not entirely sure what happened there, but I think the search and replaces at some point must have mangled it. So as I was saying, we are Homo sapiens, and of course we're very visual as a species, and we seem to do things visually a lot. It seems to make complicated things very easy to understand. So that's clearly a good thing. But at the same time, one has to ask, what is really the fundamental nature of a model? And I actually think the fundamental nature of a structural model is mainly to narrate the structural dependencies between types and to narrate the purpose of the model. And also we are storytelling species as well, right? So I think between the two sort of faculties that we have, I think in this particular case, storytelling wins over visual representation. It's all about the properties, really. And ideally, really, in an ideal world, what you really want is to have both, really. You want to have an isomorphic representation that can be converted between the two without any loss, so that, especially in an automated fashion, really. So that really is the way forward, is to be able to say, well, can you please show me the graphical representation of this? And then you'd have a class diagram that's, automatically generated, and it looks quite faithful, and it solves all the quirks and issues that we always have to solve manually. And normally you're editing the text document. And that's no different from, say, how you do UI development, right? I mean, you do UI development by largely by dragging widgets around and playing with things graphically. But at some point you need to see the code behind the widget, and no one's proposing you should do that by graphical means, right? I think it's the same thing for modeling. So that's the direction that we are going now. And hopefully reaching the end here this is all very boring, but necessary. And once we've got all of this done, fundamentally, one of the things we talk a lot about in our writings, which we haven't been published yet, but we talk a lot about the observation of patterns. And this is exactly what I mean by observing patterns. I mean, you see the regularity of this code. We almost write now code as if we were about to generate that code, which is a bit weird, really, if you think about it. As developers, we don't tend to write code that looks mechanical and repetitive. We tend to write code in such a way that looks the exact opposite. Because if the code looks mechanical and repetitive, somebody will immediately tell you, can you not refactor that code? Can you not create some functions? Can you not just, make it a little bit more less repetitive? Whereas once you start thinking like a code generator, it's a bit the opposite. You don't really want to do huge refactorings unless those refactorings, of course, are very, very static. What have we done here? We somehow managed to screw this up. Unless those refactors are, of course, compile time refactors. I think that the key thing that we've learned now is it's very important to distinguish between things that we do at compile time versus things we do at runtime. And that's something that we didn't really worry about before in the past. In the past, no one would say, well, don't do that at runtime because it's going to cost me money doing it at runtime. I mean, you have to go back to the assembler days, I think, to have that kind of way of looking at the world, right? The modern world, I don't know of anyone in the team that would say, actually, I prefer you to unroll a loop and craft this code because of the cost it has at runtime. We just don't think like that anymore. Whereas I think in a way, the more you move towards code generation, the more you start to think a bit like that. The more you start to think, well, would this make my life simpler if I unrolled the loop? And in many ways, actually, I wonder if it wouldn't. I mean, I haven't proven this yet, so I don't know. In fact, to be honest, you can't really prove it. You can just provide some empirical evidence, really. This is not something you could generalize and say, okay, for all cases, X. But you could at least provide some supporting evidence of your arguments. And I think some of the supporting evidence would be that anyone that has spent hours on it trying to figure out why Castle is not working would probably resonate with this and say, well, actually, it would be really nice if I just had some plain code that I could quickly, even if need be, debug. Because if you try debugging over the internals of Castle and so on, the problem is the code is so complicated and so domain specific that unless you're really good at DI and you understand lots of the ins and outs of Castle's implementation of DI, you're probably not going to make heads or tails of what they're trying to do. And I think, in more generally speaking, I think that's the case with a lot of this stuff. The more you start factoring things out and start to create really nice and clever code that doesn't have lots of repetition and duplication, the more you start to create infrastructure that's very difficult to reason about. It's not by coincidence. I mean, that's the whole point, right? You're trying to factor out commonalities, right? So by factoring out commonalities, you're now making the next guy that has to go and understand your code, you're giving them a tougher time, almost by definition. So the question we asked there then is between these two trade-offs. I'm not even talking about performance because, of course, there is also the performance angle. I wonder if it's not much more performant to just basically, unroll the loop manually, so to speak. But that's not really my key concern here. I think if you start by trying to make a performance argument, everyone will then say, well, it's just not worth your while. It's just such a small gain in performance, perhaps. And also, it's important to remember that we have the complexity of maintaining the code generator, which is non-trivial as well. So this is not exactly a very simple equation. But certainly it's probably worthwhile exploring, and I suspect at some point we'll write a paper on this. Just haven't had the time to do that. Still chasing the main target, really. Right, I have no idea where we are, but let's just do a quick run and see what happens. Probably are close to finishing the updates. here, I'm getting a bit bored of typing, so I'm gonna start using Emacs a bit more. So, roughly what we've just done, or we were trying to do at present, not entirely sure. Oh, I see. Okay, right. So, let's think about this for a second. We are trying to obtain the registrar. Yeah, let's just be very careful here because I think we just screwed something up. So where are we then? We're inside. We shouldn't really be modifying this guy, I don't think. Let's just go to Git and see the extent at which we change things. So I'm just gonna accept pretty much everything here. Okay, right. So I wouldn't expect us to be changing C++ code. So let's just put that back. I think what we've done in our cleverness, we modified this guy here. Yeah, I think we didn't really mean to do this. I think there's two things here, and we just assume that they're the same, but they're not. One is the actual chain, the legacy chain, I guess, and then the next one is the new thing. So, excuse me. Okay, so now we seem to be complaining about text transform registrar. Now, I'm not entirely sure why that would be, but okay. No, actually, not the generation chain, but the model to text chain. So this guy here, yeah, okay. So see, so he's got a registrar. He's that guy. And whilst we created this, okay. This is the sort of thing that annoys me profoundly with C++. I mean, why didn't the compiler just tell us that there is a function with exactly the same signature, but is a member of a class? Are you sure? You don't mean whatever. Okay. I thought we had initialized that in the very same file, but clearly not. Again, I bet you we just forgot to put the qualification. Joys of C++. Sure, this will be easier for you using Rust, but there we are. Right, so what is going to happen with this, hopefully, is well, nothing really. All that's happened is everyone is registering now against the new registrar. Okay, so that's all we've done here. So text.cpp register legacy text transforms with new registrar. Right, so where things are going to get a bit more exciting is now that we've registered all the transforms, we shall copy the workflow, this chap here, and implement the workflow and the transform. So at present, as you can see here, at present we are we're looping through the transforms for technical space. We don't want to do that anymore. What we want to do instead is we want to say, please just loop through the formatters directly. So I'm going to create a new apply here. I'm literally going to call it new apply. to apply is going to be rather cleverly a copy of the technical space specific workflows. Now we're kind of guessing that they are rather identical. If they're not, well, we should soon find out, I guess. We'll just take the C++ one, because why not? I'm going to make this really simple, so I'm not going to do any cleverness here, like creating further methods or anything like that. So we just start with this guy, noise refactor, later on. And then we will just basically say, well, take the element of the region, we're processing an element, meta name, right now. So, where we're asking for the formatter repository, really what we want is the text transform repository. I'm not really sure, there we go. And then where we're asking for the stock formatted by meta name, we want these guys instead. Perhaps we could say const auto by reference. I'll just call that RP. And here we could say RP M to T. Okay, model text transforms. And then in here we could probably simplify this to just get me these guys here. And then, so as you can see here, all we're doing now is we're just basically saying across all the model text transforms. Now we don't really want to return, we want to continue. That's why the copy and paste here has to be very careful. And then we could do something like, well, we have the LPS. In fact, for good measure, let's just start calling this by its real name, which is the LPS. Because there are many models, but the LPS is a special kind of model. And then in the LPS we could easily say, give me the physical representation, and then LPS, and then away you go. And now not entirely sure what is going on here. Seems to be we are missing some kind of if somewhere. Okay, and then where we are doing a get artifact, well, we could probably just be lazy and just take this as is. I'm sure there's probably some simplification we could do, but we are getting a bit bored. So if we just do a private here, perhaps CPP would. In fact, I'll just copy it from here. Now, because the guy was static, I think we should also be static. I wonder why we bothered with a pointer. But anyway, at any rate, we did, so we'll keep going. So this guy would do a get artifact, and we just need a couple of things here. So this is probably going to be some kind of transform error. Transformation error. I don't know why you don't call it transform error. Another thing to fix at some point. Right, so now then, let's just try to understand what we broke. Here we are. So this is the problem. So this guy here should have been indented correctly. So now let's just reason about this thing. What are we trying to say? Well, we are trying to say the following. We are saying, we have got access to every single text transform that exists across the entire physical space, presumably. Still don't seem to be very happy. What did we do here? I have no idea what we've done here, but nothing good. Okay, let's just look at the original because we mangled the code quite dramatically. Slightly better. Okay, so what we're saying then, we're saying now at the top level inside of our model to text chain we got access to every single transform that has been declared within this logical physical space. And so we can just basically say, well, for every logical physical region, locate the transforms that match. In fact, let's just stop using names like formatters because I don't really want to use this legacy. Don't want to really use these legacy names in the new code because we are trying to clean up terminology. So we certainly don't want to go back to that. So this is a text model to text transform, and these are, in fact there can be several of them, so we just have to be careful here. Model text transforms. So we just basically say these guys are by meta name, and these guys are actually the real deal. These are just basically all the model to text transforms. And then there's a pointer, that's fine, and this is a multi-text transform. And then at this point we can just inspect its nature, and this is a physical meta name. And then the physical meta name you can get the archetype, and with the archetype we then query the logical physical region, and then there we can determine whether this chap is enabled or not, and it's fine. So we're processing an element. Basically we should say somewhere around here which archetype we're processing. Makes more sense to say this because it's the archetype. So here we say we're processing archetype, then we could just say whether it's disabled or enabled. You know the name, so it doesn't matter. And then we could just say model to text transform. Now we just have to be very careful what we're saying here because we already obtained the archetype meta name. That's the physical meta name. We already have the ID. So if all we're trying to do is obtain the value, in fact, why do we even need the value? Because we don't seem to be using it anywhere. So let's get rid of that. And there we are. So now this code is very, very tidy. It is more or less reflecting the new understanding of the world. And you see here what I meant, right? What we're doing here is we're looking through all the register transforms and doing all the processing, but nothing would stop us from having a specific code that actually includes every single file and then runs each transform. It will be equivalent, and it will be much easier to understand, and if there's a problem, much easier to debug. But of course, no one is going to do that 80 times. That will be quite painful. So you end up pushing all these things to runtime. Now what we'll do is we will run these tests. Now nothing is going to happen now. All this is doing is validating that it compiles or not. And if it doesn't, we need to know why. So we're missing an include forward. This repository is really not helpful. It's just the ID. So let's just go back to here. Probably well, just grab all of these IDs because sooner or later we'll need them. purpose of this will be to just get this thing to compile. Okay, that's good. So what we were trying to see is how long our recording is going. So that's good too. So let's just call these implement chain. Implement the non-TS specific model to text chain. Right, now then, what we can do now is slightly exciting, I guess, is to replace the existing apply with a new apply. And that will be done from the guy that's calling us. So the model generation chain. So as you can see here, what we're doing is we are calling for each model text chain.apply. Now, I wonder what would happen if we called the new apply instead. Not quite what I meant to do. So what we expect to see at this point is if everything goes according to plan, this should result in exactly the same code. In other words, nothing should move. All tests should pass. But the difference is we're now going via, we're basically bypassing all of this. Bypassing these guys, that guy, this guy. In fact, we're bypassing all of the initializers as well. So this will be, if works, will be quite significant. Of course, it didn't work. Now then, let's have a look. It is interesting that the differences are coming not from everywhere. But that is actually quite interesting. I mean, I would have thought you'd either break everything or succeed. But no, it's actually only broke half of the things. This is always the way, isn't it? So at least we see both C++ and C# problems. We see that in the C# reference implementation and the C++. Okay, right. But part of it is some more specialized models. So this directory settings is a very, very complex model that exercises a lot of complicated variability. So we'll ignore that for now. This is the language agnostic model. Okay. It seems as if we are executing C#. Indeed, we are executing C# when we shouldn't have. Okay, so this is not too bad. I think we're just missing a tiny thing. So I'm just going to pause for a second. Usual chaos. We're back now. So yes, in a way, this is not too bad, really, if you think about it, given the size of the change. All that's happened, surprisingly, is we are not taking into account enablement and disablement of C# models. So, that being the case, what we'll do is we'll just have a quick look. I mean, I assumed that the enablement would have been sufficient here. There must be a higher level check that has been done, I suspect. Like this guy here. Let's make sure we're recording. Yeah. So this guy here. So no checks here. We're just doing whatever. Again, no checks here either. So where could that check be? In the workflow itself? So here we're not checking anything, we're just doing it. And finally no checks here either. Okay, so let's look at the old apply. Is there anything special here? Okay, there is some kind of logic going on here. some technical space level logic. Aha, what is this? Yes, so we do have some technical space level logic here. There's two ways of going about this really. We could say, because if you can imagine what's going on here is the following. At present, we are registering each of the transforms against the technical space registrar. And then that enables us to say, if that technical space is off, don't bother doing any of these. And that's clever. However, in the future, in the new world, what we're saying instead is, I don't care where they come, the transforms, I'm registering them into one big old global repository. And now, whilst that sounds very clever, the downside of that is that we can't switch off all of the transforms in one go for a given technical space. But we could potentially just do a check and say if a backend is disabled, as long as there's a way of knowing what the backend is, that is the crux of this element, of this question really. Is there a way of knowing for a given model to text transform without doing too much work as well, right? I mean, so we have two options here. There's the complicated option, which is we should segment these transforms by backend, not just by meta name. And we could just register them like that. I mean, this doesn't sound awfully complicated. But then, if you bear in mind this is a temporary thing, and we're going to change this in a second, and the way we're going to change it is a much, much better way of doing this, because we will then just basically execute them in order. We'll just ask the backend to run, and then we'll ask the backend to run all the transforms, and then that will then run all the individual text transforms without any registration. So that's the future, the very near future. So let's just not waste too much time on this. We just need a quick fix for this problem. Now the quick fix is basically to say this code so we need to somehow convert from a given archetype to its backend ID, and then to know whether that backend is enabled or not. That sounds easy enough, I guess. I think we have a factory somewhere in identification that does this sort of crazy thing. Let's have a look. So we have an identifier factory, something to do with physical meta IDs. Physical meta ID builder. Yes, here we are. So this guy here, given a physical meta name, it gives you a backend name. So what exactly does this thing do? So if I give you a physical meta name, it takes a location, and then with that location, well, I'm going to give it a go using this guy. What this guy will hopefully do is enable us to quickly convert from the ID something like using this is actually a helper, isn't it? Right, so if we just take this guy, is this statics? Yeah. So if you just take the this guy, and if we just do something like backend, let's call this a backend ID. backend, and then we take the PMN, and then we can just copy all of that logic around here. So the idea then is basically that we so let's go to the LPS. Well, we already have MMP, so let's not bother with that. Now first we obtain the backend ID. So the idea then is to do a find of the backend ID. If that exists, then it's good. I think so. We don't really... Yeah, no, I think the backend is fine, so... Right, so... Now we just have to be very careful with what exactly we're saying here. So, ensure the transform for the required technical space is marked as enabled. If it is disabled, the user requires conflicting options. Output on technical space X, but disable backend for technical space. No, I'm not entirely sure I understand this logic. But to be honest, before we do anything else, let's just see what exactly happens when you try to run it. Before we start to... okay, right, so this obviously blows up. Right, I think now we can't use this logic anymore. I think if it's not enabled, continue. I can't quite explain exactly why this is the case, but again, we just have to bear in mind that we do not care particularly about this logic here. As long as it gives us the right result, we don't particularly care, because the future is not this logic. The future is to co-generate the calls to the transforms, and that will then take into account all of this rigmarole of enablement and disablement. So this did not seem to have done the trick. We still have exactly the same diff. Now let's try to think about why that would be. Seem to be generating C# files when C# is disabled. Most peculiar, you would have thought if the backend yeah, okay, I think we reached the end of our understanding of this now. We're just gonna have to think about this for a second. We don't do this in any case other than directory settings, lam, directory settings, lam, directory settings in lam. Okay, so these are the cases where we generate both C++ and C# models. So there seems to be some kind of conflicting option that is causing this. However, I would have thought this would be triggered. So if I just open up one of those models, so if we just go here and say, in fact, let's make sure no one's talking to me. A few messages, 1 second please. nothing major. So what we're trying to say then, we are trying to say directory settings model. So if we take something like C++ reference directory settings, let's get rid of the ruler. Right, as you can see, it's high on configuration, this chap here. But somewhere around here, there should be C#. Ah, interesting. We never actually disabled C# in this model. Oh, that is most peculiar. So we never did disable C# explicitly, so it is enabled. Why did it work so far? Because the output technical space is C++. So C# is enabled, but since the output technical space is C++, we should just never... Wow, so we just found a bug. Just a logical error, really, that got uncovered by this merging of things. So up to now, we generate technical space specific representations of models as part of the logical pipeline, and then that then triggered the representation then maps against the technical space specific model. And so what we do is we say, well, if you're a C++ model, just go to the C++ representation and then just run the transforms. And that then meant that if you were a C# model, well, we never find the C# representation because that was never required. So what we're now saying is, in order for that to continue to work, we need to take into account the fact that the output model is also not of the type of the transform. So what is available on the M2T? Is there a technical space? We can apply, there's an archetype. The archetype I do not think has a technical space, I don't think. Ah, it does. Okay, so the archetype has a technical space, and there's the element. Well, it does have an intrinsic technical space, but that's not quite what we're looking for. Is there any other technical space in the element? In effect, the mapped technical space. You can see the complexity of this is quite high. Definitely need to simplify things a little bit. So you'd have thought an element would have an associated technical space because it's been mapped to that technical space. I'm not sure why I can't see the intrinsic technical space either. This is where clearly it would be nice to see this in org mode and just do a Control S. Here we go. So we just have an intrinsic technical space. Now that's not going to help because I think the intrinsic technical space of a logical model element by default is some kind of generic agnostic technical space. So that's not going to help. But what could help is output technical space. Right, so we know for sure. Right, we're going to do a bit of hacks here. So if I just do something like we know for sure there's one. I mean, okay, I should really check, but let's just double check this for now. So if the OTS is different from the TS, we can just basically say skipping space. And well, we could probably call this M2T TS. Not quite sure what symbol that is. Is that not equal to? I think maybe we are not in the English keyboard. That does not look like. That does not look like a bank. Now we seem to have collapsed. There we are. Oh, that looks a bit healthier. So if the output technical space is costs auto. So if the output technical space is different from the, and then we could just basically say we are skipping the M2TTS and continue. Right. So now we have two levels of checks here. First thing is if the top level technical space which we are writing is not the one we're interested in, then bomb out. The second thing we do is we check enablements for the technical space. For the specific backend. So hopefully between one of the two, we're gonna grab the thing that's causing the problems here. With a bit of luck. Of course you can imagine this is a rather expensive way of doing it. The other way was much more efficient because we were just doing once. Ah, no. Okay, now then. Ah. Now we've gone a bit too far. Sadly, that is not going to work because the minor technical spaces are now not the same. Things like CMake, for example. Wow, this is actually going to be quite a tricky thing to fix. Perhaps the fix is going to be to say that you need to disable the sorry, we're just gonna have to do a fix that is slightly less nice, because otherwise this is gonna become really unwieldy. So what we're gonna do instead is we're gonna say for all of these models you need to explicitly disable C#. I know this may not be the nice fix, but we have to bear in mind that the reason why this is happening is purely because of the way the code's structured at present, and that's really not the right way. So we want to make the fix that takes us the least amount of time, else we'd just be throwing away good time after bad, good money after bad. So all we need to do here is to make sure that 4 models are going to have the right settings. Right, so now this is of course not brilliant, but it's good enough. So in this case we need to do the opposite. So mas.c# dot mas.c++ enabled equals false, and similarly when you're running a lamb model, and as you can imagine this is not a problem for all other models, because in all other models we were already doing this explicitly. It just happens that in these models we didn't. The reason why is because in the past we actually were using one model to generate both C++ and C#. We had to move away from that. Okay, so the way we're going to test this now is we're going to basically say, first we need to make sure we're using the right branch. So this is pointing to master. So instead of master, let's just move over to integration, because we made the changes in integration. And that's now going to result in halving of the 10 tests that we had broken. And then we will change the JSON models, and hopefully that will resolve the other 5. Although I think we changed 4 models, so interesting. Right, now we have another problem. The minor. Oh, actually, to be fair, it doesn't seem to have done what we thought it would do. Let's just double check that we are not looking at JSON. No, this is definitely a dia model. So, and we are definitely looking at integration. Yeah, integration C#, integration C++. Okay, that's good. So the C++ ref impl is generating a CMake file. Actually, that is a bit surprising. You would have thought that wouldn't be a problem. I mean, you should be generating a CMake file for C++. Similarly, you would have thought you should be generating serialization and so on. Unless, of course, we disabled all of these facets. But we wouldn't, because these are test models, so it shouldn't be disabled. And then, what else we got here? Okay, this is interesting. We seem to have a different kind of error now. Right, let's have a quick look at what's going on here by jumping over to the models themselves. If I just create another area here, let's call that C++ ref impl code, perhaps. Right, so what this thing is saying at the moment is that we should not, in the directory settings, should not be generating. Let's use 3max here as well. Okay, I see. Okay, okay, this is just another nonsense here. We need to, because we explicitly disable the backend, we're no longer generating the backend directory, which is really annoying. We're just kind of falling into some kind of variability pit at the moment. There is a way to force that to come through, and I think directory settings had it, funnily enough. What is directory settings? C++. Yes, we need a way to force the backend directory to come through. How did we used to do that? Perhaps the path, legacy path transform. There must be a backend directory. Enable backend directories. Okay, so how do we enable backend directories? Must be some variability in the logical model. It's a shame, we're so close. The problems that we're having at the moment are just annoying problems. They're not real problems, they're just time-wasting problems. Sadly, this is where recording is a disadvantage, because now I can't focus properly. This is just a tiny little change. In fact, let's just go back to our... what do we do? Right, if I quickly jump over to our org representation, I open up the well, actually, I'm just not even bother with that. I'm just going to grep for enable backend directories, and then interesting enough, seems to only exist in the physical model. Makes sense, really. It's a physical concept, so I would have thought we'd see something around here. Enable backend directories. Here we are. So what we're going to do is say mas.physical. Right, let's take this guy here. Of course, you can't copy and paste to add to our annoyances. It'd be nice to be able to copy and paste, but we can't. So Dogen mas.physical enable backend directory equals true. And if we just repeat that exercise a few times, four times to be precise, and then another four times for the JSON, but that will be easier. Okay, and finally, and here you can really see why software development is a pain in the backside. Sorry, I think I hear some noise from downstairs again. Alright, we're back again. We're running out of time slightly, so hopefully this fix is going to really fix it, because I suspect this is the last thing we can try. Alright, so by forcing the backend directories, hopefully let's make sure we are recording. We are indeed. So by forcing the backend directories, we are now hoping that a good chunk of the errors are going to go away, and that is correct. Now I still wouldn't expect 6 to stay, so that to me implies that we missed a model. So JSON, 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 dia. So C# model. So the C# ref impl. C# model. We missed the C# model. That would be a very good explanation, because sorry, let's just go back to that directory and find the C# model. Right, if this one, I think we can just get away with disabling. Oh no, we've already done that. Oh, that's interesting. Why is the C# model failing? I wonder if... oh, wait up. Directory settings. Okay, right. What's this? What's this? That's actually a bit more worrying than the previous problems. Handcraft sequence generator and handcraft dumper suddenly disappeared. Which, to be fair, actually that is correct. So we just solved the bug. As you can see here, this is typable only, so it should only have types. So okay, so that is actually not a bug, that's actually a real problem. So we resolved that, which is another good thing of having a single sort of way of going through all these things, because we were doing something special for C# that was wrong. Okay, so that's good. Right, now then, last fix then before we finish this video. So if we just go to each of these models, in integration again, and we just need to repeat what we just did for dia. In fact, if I just do a diff, just see these two little incantations here. If we just go to, not quite what I meant, to JSON, so we have to go to directory settings, and in directory settings we need to do something like C# enabled false, and okay, something like this. That sounds reasonable. And then the same thing for lamb, presumably, where we want something like this. And now if we go to the C# version, we need the opposite. So not dia, JSON, but directory settings. So in this particular case we want to say something like C++ is enabled false, and the backend directories, and the same thing for lamb. And right here. Okay, so now we expect our errors to go down to 2, which is just basically the two C# models, JSON and dia. Okay, excellent. And then if we simply build a new code generator, and then if we jump over to, in fact, area 21 perhaps, let's call that C# simple code, and in here we just need an E shell, which we probably should rename to C# simple, and then just need to know where we are. Okay, we are. So if I just do a generate here, perhaps a dia. Okay, that's not going to work. So we need a path to our build. So that's going to regenerate everything. I think that's going to cause some problems. So yeah, we don't want the byproducts. See, we just deleted the files that we didn't think should be in there in the first place. Now we have a whole load of changes there. Now finally, we just run all tests. Finally, we should get a green build. Now I wanted in this video to also do the cleanup, but given we already are an hour and a half into it, okay, there we are, green build, amazing. So what does that green build tell us then? Modulus. Okay, not sure why I have some differences here, but we've got everything more or less up to date in the diagram. So what does this green build tell us? It tells us that the registrars that we are got here are now working. So the next step will be to remove all this stuff, remove all of the models technical space stuff, and we will end up with just a model to text chain, which then makes use of these two guys here. Now I'm not going to bother doing that in the video because sadly we've run out of time and I need to do other stuff. But it should all be very straightforward because we're not using any of that code, so it's just going to be a removal of the last workflow, plus all of these guys here, plus probably the traits, plus all of the initializers, and that's it. That's what we're going to do to clean up. But what we'll do now is, of course, we can commit this, but of course we can't commit until we commit all and push all the stuff we have in the language model. So make sure we have all the changes staged with the commit. This is just minor version changes, so it doesn't really matter. So let's just basically say generate with latest Dogen, respect enablement settings on handcrafted class, disable C++ explicitly, disable C++ backend, explicitly enable backend directories. Right, these are two things we needed to do in order to achieve our objective. And then here we could just basically merge and push. So that would be the C# done. And if I just jump over to C++, okay. What happened here? Oh, sorry, we're in the wrong place. C++, I said. Okay, here we go. So I think we probably can do exactly the same comments. Would take us almost there, and then we just need to go to master and merge and push. In fact, to be honest, I think I did not push to all of our clones. So let's do that now. Right, so that is that for that guy, and then in here we could say something such as text use new text transform infrastructure. Okay, and that's also ready to be pushed. As you can see here, we don't have a problem of pushing this sort of temporary code. It doesn't really matter. The key thing is, as long as it works, it doesn't really matter. So okay, that is it for this video, and I probably will do the rest of the cleanups before the next video, and then the next video we'll be focusing on trying to move the first text transform, I think, which makes more sense because at least it's a new task. Okay, that's all for this video. Thanks for watching.